Okay, at this point, guys, if we've now ensured that the user enters something for user and password, username and password, and now we're going to set up our accounts. I don't remember what the comment was before. I've lost the code. I just remembered it over the years, so this probably looks a little different. Now, I'm going to do a little check here. Remember what I said, guys. True and true. When you're using the and, that's the only one that evaluates to true. So if we want to make sure both username and password match, we've got to use and here, because that's the most secure, where both must evaluate to true. Like I said, this comes from Mike Dawson, so we're using his username. I believe this is how he coded. But notice, when you're using, this is a compound comparison. Compound Boolean comparison. Compound because we have more than one Boolean comparison. Both this and this must match, or else it's not going to evaluate to true. So in this one, we'll print welcome Mike. We'll set security to 5, which apparently is a high security setting. And let's go ahead and just test this out. So we go ahead for username, type it out. And at this point, we have a welcome Mike. Let's run it again and try something different. Now, in this case, there is no welcome Mike. So what we want to do here is we should set up a catch-all for when things don't work right. So we're going to do an else, and we're going to print here password and usernames must match. Run it again. We'll try what we did before. And now it says password and usernames must match. Of course, we could put a while loop that makes us go back and do this again. Let's run it again. Let's test it this time with the wrong username. We'll try B Gates. This time the password will be correct, but the username is not, and it still evaluates to false. And of course, I probably don't have to tell you, but you can go ahead and test it if you really want to try it out, and just put Fred, where neither of them match, and no matter what, doesn't work. So there's our first sort of setup for making sure usernames and passwords must match. And so we can do other checks for other usernames and passwords. If we do that, we need to add an elif instead of an if. So we're going to write an elif. All right, so let's say we're going to do username equals b.gates and password equals mslove. Again, actual any reference to actual or living founders of Microsoft and their password is purely fictional. Maybe he gets a security level of 10. And let's go ahead and test that one out. It's always good to test out each of your possible conditions. So in this case, we're going to try B. Gates and MS Love. Welcome, Bill. Let's run it with the wrong username and password combination. Notice, doesn't work. And again, the only one that works are where both evaluate to true. Now, we're going to do, let's take a look at the operator called OR. Remember what we did before, true or false evaluates to true, because either has to be true. As long as one of them is, the whole thing is true. So let's use the OR for a less secure setting, and let's think about, what about guests? So what we're going to do is we're going to do another elif, and this time, username can be equal to guest, or password can be equal to guest. And it doesn't matter. As long as one of those evaluates to true, we're good. And we'll set security 1 because they're guests, so we give them less privileges or whatever. Now, obviously, there's no way you would ever want to write a program that had that lax of a security. Okay? We should never hard code actual passwords where you can read them. And there's a lot more coding that would go into trying to make sure this was secure. This is just for illustration purposes only, of course, mind you. But let's try guest. And as long as either username or password is guest, it will evaluate to true. So we run it. We say guest at welcome guest. See, the username was guest. Let's do it where the password is guest. And there it's welcome guest. And then we do guest and guest. And that works. And neither of them, if they both evaluate to false, it's false. So as long as one of them is guest, either username or password or both, they all evaluate to true, they all get run. And now we've used not, and or. So we've used all the different, these are the logical operators. And then if you get really good at setting up for your Boolean comparisons, you can do things like determine whether it's a leap year or not. So I'm going to leave you with the Boolean operation that determines whether a year is a leap year or not. So it is now 2015. I can tell you for now that it is not a leap year. So in order for it to be a leap year, it has to be evenly divisible by 4. And if it's not evenly divisible by 4, it's not a leap year. But something that is evenly divisible by 4, like if it's an even number year, like on the hundreds, like 1700 is not a leap year. It actually has to be evenly divisible by 100 and evenly divisible by 400. Or, I mean, it cannot be evenly divisible by 100 unless it's also evenly divisible by 400. Okay? So what we can do is we can find out if it's evenly divisible by 4, but not evenly divisible by 100. And then we can then see, or if it's evenly divisible by 400. So how that gets set up is like the following. And by the way, we're going to need some parentheses here to figure it out. Okay, so in the first set of parentheses, we're going to put year modulus 4. That means divided by 4, what is the remainder? If the remainder is 0, in fact, let's just test that out. That's false. And then let's change year to 2012, which is evenly divisible by 4. run it there. You can see that that's true. Okay. So that's what the year divided by 4 produces a remainder of 0 in the case of 2012. In the case of 2015, you divide it by 4, the remainder is 3, so that would evaluate to false. 2015 divided by 4 is equal, or modulus 4 is equal to 0. So this tells you whether it's evenly divisible by 4 or not. So it has to be evenly divisible by 4, but not evenly divisible by 100. Hold on, I got to put is equal to 0. Okay, we're going to have to expand this out a little bit. Sorry, folks. And let's put a little bit of spacing here. So, actually, I'll reduce it. So, year divided by 4, if the remainder is equal to 0, and the year divided by 100 is not equal to 0, or year divided by 400 produces a remainder of 0, like so. So that's year of 2012. Happens to be a leap year. If year is 2015, it should not be a leap year. If the year is 2000, that becomes a leap year. But the year of 1700 should not be a leap year. And at this point, we've also used and, not, and, or to create a compound comparison that actually tells you if the year is a leap year or not. So there you have it. There's our logical operators in the context of both programming and just in general. Thank you for watching.